Carbon can come in another form called graphite. Now, in graphite, every carbon is covalently bonded to 3 other carbon atoms. So what happens is we end up with a hexagon shape, and these hexagon shapes actually end up forming giant layers. So graphite forms these giant layers, and these layers actually have weak intermolecular forces between them. Just like I spoke about in my small molecules video, every substance has got weak intermolecular forces. Now, with regards to graphite, these weak intermolecular forces between these layers means that the layers can actually slide over each other, and that's why graphite is soft. Now, another thing to note about graphite is that it also has a spare electron at each of its carbon atoms. Now, remember, carbon is in group 4. It therefore can make 4 covalent bonds because it has 4 electrons in its last outer shell. Well, because it's only covalently bonding with 3 other carbon atoms, what that then means is that one of these electrons in its last outer shell becomes spare. So what that means is that these electrons are actually free to move, and we call them delocalized electrons. Now, I have used this term before when I've talked about the movement of the electrons in metal bonding. So if you understand about delocalized electrons, electrons that are free to move, you should therefore know that graphite can conduct electricity because of these delocalized electrons.